All right, guys, today we're going to talk about classifying triangles, both on the coordinate grid and not on the coordinate grid. So let's add that to our notebooks. Oh my word. A little behind here. So 45, 46, 47, and 48 were all our 2-column proofs. And so then now we're on 49 and 50. And we're going to talk about classifying triangles. So less about proving that they're congruent to each other and more about when I look at one triangle, what do I call it? Like, how do I name it appropriately and all that fun stuff. So yeah, let's take a look. So, some reminders over here because we did talk about this before. We talked about ways to classify triangles, and just some reminders about if we are looking at a coordinate grid, how we should do that. So how do we find the length of something on the coordinate grid? So to find the length is just another word for distance, and we had the distance formula, which was like that big old square rooty thing. We're subtracting the x's and squaring them, subtracting the y's and squaring them, adding that up, and then square rooting it. Or we were kind of low-key doing the Pythagorean theorem, which was like c squared equals a squared plus b squared. But then I square root it to get c by itself. And we were kind of doing that by using slope. So again, not to be overwhelming, but to do that, to find that distance, what we actually ended up doing was like rise squared plus run squared and then square rooting. Now, length is important for classifying triangles because based on the length of the sides, my triangle is either scalene, isosceles, or equilateral. So based on if I have I should say this a different way. Based on if I have 3 congruent sides, 2 congruent sides, or none, that will tell me if I am equilateral, isosceles, or scalene, and we'll get to that. Now, the other thing that I can do on a coordinate grid is I can figure out if something is perpendicular or not. And that's useful because then I can classify the triangle based on its angle measure. So a triangle can be acute, obtuse, or right. But I can't measure acute or obtuse on a coordinate grid, but I can measure right on a coordinate grid because that is perpendicular. So to remember how to figure out if it's perpendicular or not, we need to look at the slope, and they need to be opposite and reciprocal of each other. So it's actually not so bad to do this on the coordinate grid because if I'm using slope here to figure out if something is perpendicular or not, I can use it again up here to figure out how long it is. So I'm really only finding slope, but then doing 2 different things with slope. And again, perpendicular is important for classifying triangles because I can decide if it's right or not. So right triangle or not. Because a right triangle has a right angle in it. And if something is perpendicular, it's got a right angle. So, alrighty. So this is kind of the same stuff that we already said. So some things to use, find the length of the sides. I always like to find slope and do rise squared plus run squared and then square root it. I just find that to be the easiest. And then to figure out if it's right or not, you're going to find your slope and compare it. Is that opposite and reciprocal or not? So again, Slope is really used in both these. That's why I like to just use slope. Now, when I classify a triangle, again, it can be classified two ways. One way is by the angles. And so an acute angle is like less than 90. Obtuse is greater than 90. Right means exactly 90. You can also classify your triangle based on how many sides are the same. So if none of the sides are the same, you are called scalene. So I can be acute scalene if all my sides are different lengths and all my angles, didn't mean to have that little hanger, are less than 90. So all my angles are different, less than 90. All my sides are different. They can be any measure. I could be scalene obtuse if all my sides are different and then I have an obtuse angle in there. So you'll only ever be able to have one obtuse angle. That looks kind of right, but just trust me, it doesn't. Sorry. But you can only have one obtuse because, I mean, you can't have two obtuse. They have to be bigger than 90. And if you have two angles that are bigger than 90, that's going to add up to more than 180. So that can't happen. And again, all sides are different because we're still scalene. You can also be a scalene right triangle if you have one right angle and then the other two will definitely be acute because they have to add up to 90. So each one would have to be less than 90. And again, all your sides are different. You could be, instead of scalene, so all sides different, you could have two sides the same, and that would be isosceles. That didn't fit in there. And isosceles, again, means that we have two sides the same. So I could be acute isosceles. Again, if all my angles are less than 90, and I have two sides the same. Now, the cool thing is, though, if two sides are the same, two angles will also be the same, and they will be the ones directly across from those sides. So this one will be different. Now, that makes me remember, I should maybe mention that up here, when all the sides are different, all the angles will be different. Okay? So when two sides are the same, two angles are the same. I could be obtuse isosceles. Again, if I have two sides the same and one obtuse angle. So like, let's pretend that that's obtuse. I tried. I'm so sorry. Again, the other two, though, across from my congruent sides, will be the same angle. I can also be right isosceles if I have a right angle. Now, the thing is, though, on your right triangle, the two sides that have to be the same are the ones that are joined up with the 90. The one across from the 90 will always be longer. And we will talk about why that is more later. Which also, then I can figure out what the other two are. Because, okay, if these two sides are the same, then the two angles opposite are the same. And they have to add up to 90, because then the other one's 90, so 180. So if they have to be equal, if I split 90 in half, each one is 45. So that's kind of cool. All right. If all three of my sides are the same, then I'm called equilateral. Really doesn't fit, but it kind of like explains itself. Equal, so all equal. Lateral means sides. So I can be acute equilateral because if all my sides are the same, all my angles need to be the same. And if all my angles need to be the same, and the three of them have to add up to equal 180, and they all have to be the same, then each one has to be 60. And I can't ever get an obtuse equilateral or a right equilateral, because like if all my sides are the same and all the angles have to be the same, I can't have 3 90s in a triangle because that's too much. And I can't have all 3 obtuse angles be the same because that would be too much. It has to add up to equal 180. So these 2 triangles are not possible. Like you cannot make those. So we can use that information to help us classify triangles. So if I draw this one out in our grid right here, if I plot A at 0, 0, B is going to be at 1, 2, 3, 1, 2, 3. And then C is at -3, 1, 2, 3, 1, 2, 3. And we get our triangle right here. You can always make a guess, but to know exactly what type of triangle it is, we have to do some stuff with slope. So I'm going to find each of my sides. So AB, BC, and AC. And I'm going to find 3 things. So I don't really need the slope, but I still find the slope because that will help me to then find the length. Oh no, I do need to find the slope because then that'll help me figure out if it's right or not. And it'll help me find the length. So that's good. So for AB, to find the slope, I need to start at A and go to B because A is leftmost. So if I count, I go up 1, 2, 3 over 1, 2, 3. Up 1, 2, 3 over 1, 2, 3, which is really just like low-key 1. Boop. Then I'm going to find the slope of BC. Now BC, I have to actually start at C and walk to B. So I don't go up at all. I just run 6. So like I went up 0 over 6, and 0 over anything is 0. And then last but not least, to find the slope of AC, I actually have to start at C and go to A because it's leftmost. And I would go down 3, right 3. Oof. So down 3, right 3 is -1. So what I can tell right now is that my triangle is a right triangle because 1 and -1 are opposite reciprocals of each other. So this is right. Now I can find the length by doing rise squared plus run squared because I have those. So 3 squared plus 3 squared is going to be 9 plus 9, which is 18 square rooted, and I don't know the square root of 18, so I'm just going to leave it like that. Now here I need to take 0 squared plus 6 squared, which 0 squared is just 0, 6 squared is 36, and when I add those up I have 36, and the square root of that is 6. So I can already tell it's not going to be equilateral. Also, I knew that because I can't be right equilateral. And then lastly, -3 squared plus 3 squared is still going to be 9 plus 9, so 18 square rooted, which I still don't know. So because I can see that 2 of the lengths are the same, that makes me isosceles. How are we doing on time? I wish I could see how long I've been doing this, but that's fine. We'll do another. Classify the triangle. So -1, 2 is P. Q is at 6, 3. 1, 2, 3, 4, 5, 6 is Q. T is at 0, 0. Oof. So I feel like my guess is that this guy kind of looks obtusey. I'm not going to be able to really know for sure, but I will be able to tell that it's not right. And then I'm feeling like maybe it's also going to be scalene, like all these sides look different, but maybe those two are the same. So again, to kind of figure that out, we want to take all of our sides, so PT, TQ, PQ, and we want to find 2 things, slope, and length. And so to find the slope of PT, I'm going to start at P and go to T because P is leftmost. And so I have to go down 2, right 1. So down 2, right 1. There's really a slope of -2. And then if I do TQ next, I don't need to rise at all. I'm just going to run like 6 again, I think. 1, 2, 3, 4, 5, 6. Yep. So 0 over 6, which is 0. And then for PQ, again, I have to start at P because it's leftmost. And I'm going to go down 2 and then over 1, 2, 3, 4, 6, 7. So down 2 over 7, which doesn't reduce at all. So when I look through these slopes, none of them are opposites of each other because I got negatives and 0. So they can't be opposite reciprocals. So it's not a right triangle. So not right. Then to find the length, I'm going to use rise squared plus run squared and then square root it if I can. So I have to go back to my non-reduced slope to do this. So -2 squared is 4. 1 squared is 1. So we got square root of 5. Over here, that 0 and 6 again, I already did it. So like kind of already know that it's 6 still. And then this one down here, we're going to do -2 squared, which is 4, plus 7 squared, which is 49. So this is going to be the square root of 53 squared. Or no, just 53. Square root of 53. Don't know. But it's not the same as square root of 5. Also, it's not 6. So all of these are different, making it scalene. So I'm going to leave the last one because now I want to jump over and take a look here. So remember, acute means all angles are less than 90. Obtuse, we're going to have 1 greater than 90. And for right, we're going to have 1 equal to 90. For scalene, that means all sides and really angles are different. Isosceles, we had 2 sides and really angles are the same. Now in this one here, like this side is congruent to that one. And so it'd be this angle and that angle. So this one's different and this one's different. Okay, so you always have to go with the ones opposite. And then last but not least, if we are equilateral, that means all sides and angles. So all sides and angles are the same. And specifically, the angles will always be 60. Love it. So that helps us to do some algebra. So if we take a look here, with this one, if I'm going to solve for x, like, I don't know. I don't know. But I can always add up to equal 180. So we do x plus 15 plus x plus 65 equals 180. Combine my like terms. Subtract the 80 both sides. And so I get that x is 50, which then does show me that this is all acute because this angle here would be 50. Oh, it's still acute. This angle over here would be 65. But it is isosceles because like I got 2 the same. Fun fact. Now, underneath that, obtuse. Again, I can solve for x here. I mean, really just because I can do the triangle sum theorem. So x plus 25 plus 20 equals 180. Combine my like terms. And then subtract the 45. So 135, which shows me that one angle is obtuse. And then lastly here, one angle is right angle. You're going to notice that you have a box. So kind of the shortcut way of doing this one is, since one of them is 90, the other two will have to add up to equal 90 as well. So I can just add them up to 90 if we want to do that quicker. So I combine my like terms, subtract the 20, divide the 2, and I get that this one's 35 and that one's 55. Now, if we go along the side here, if I know that the perimeter equals 30, that helps because I can add all these up, because we're talking about the sides, and set it equal to 30. Because if I add all the sides, then that's the perimeter. So I combine my like terms, and I'd have 16x equals 30. Oh my gosh, did I add that? I did. That's 15. Oof. Divide by 15. So x is 2. And then I could find each side, because this one would be 12, that would be 16, that would be 2. Wait. Oh my god. Did I do that right? Yeah, okay. All right, down here, if it's isosceles, then that means two sides are the same. Also two angles. But if these two sides are the same, I can just set them equal to each other to solve for x. So in this one, I'd have to get my x's on the same side. So I'd subtract the x. And since it's going to be over here, I'd add the 5. So 20 equals 3x. Ooh. Yuck. I'm just going to leave that as 20 over 3. And I'm not going to plug it back in. Last. If it's equilateral, then all your sides are the same. Now you can't set all three of them equal to each other at once, so you just pick and choose. So I'm going to go with this one, x plus 9, because that's easy, and set it equal to this other small one here that also doesn't have a negative number in it, because I can choose whatever I want. They're all the same. So then I want to get my x's together, and since x will be over here, I also want to get rid of the 4. So I get that 5 is equal to x, and you can test me on this one too. If you want to try setting up the other two and see if that works out, you could, but any way you do it, you should get that x is 5. So good luck, guys.